Welcome back. In this video, we're going to look at another class of alkanes called cycloalkanes. This is part of a bigger class of hydrocarbons called cyclic hydrocarbons. And you can probably tell cycloalkanes are a little bit different from normal alkanes in that a cycloalkane is a ring. It's a cycle of carbon atoms. And with the cycloalkanes, the root is a chain that is part of this cycle. A little brief intro, though, into cyclic hydrocarbons. Cyclic hydrocarbons have a very prominent role in biochemistry. A lot of important molecules are built off of cyclic hydrocarbons with 6-membered rings or 5-membered rings. One of the ones I've drawn in front of you is the molecule for cholesterol, and you can see that it's got 3 6-carbon rings and 1 5-carbon ring. There's other hormones like cholesterol, very similar structures to it, like testosterone, progesterone, that are also built using these rings of carbon. So in this video, we're just going to have a look at cycloalkanes, and then in a second video, we're going to have a look at cycloalkenes. All right, so what's the deal with cycloalkanes? Well, cycloalkanes are when we get a chain of carbons that link back onto itself. So instead of a straight chain, we have a ring of carbons. And the smallest ring of carbons we can make with single bonds between carbons is a 3-membered ring. And when we look at a 3-membered ring, each carbon has bonds to 2 other carbons, which leaves it room for bonds to 2 hydrogens. Okay. Another way that I could write this is with a line structural formula, and it would look like a triangle. Okay. The next one, if we add a 4th carbon, would be this one, which looks like a square, and once again, each carbon would have 2 hydrogens bonded to it. And if we use a line structural formula, it would look like a square. And hopefully you're starting to see a bit of a pattern. You know, if I increase my number of carbons, the line structural formula would look like a pentagon. And then if I add a 6-carbon ring, it starts to look like a hexagon. All right, what do the names look like? Well, there are 3 carbons in this ring. So 3 gets the root name prop, and because it's a cycle, what we do is we just add the prefix cyclo in front of it. So this becomes cyclopropane. Ane, meaning that there's nothing but single bonds between carbons. Prop, meaning that it's a 3-carbon, it has a 3-carbon root. And then cyclo, telling me that it's a ring of carbons. And you could probably guess what the remaining 3 are. So a 4-carbon ring would be cyclobutane. A 5-carbon ring would be, oops, can't spell, cyclopentane. And a 6-carbon ring would be cyclohexane. There you go. All right, with cycloalkanes, if we add a branch, that's fine. We just need to make sure that we number branches so that branches get the smallest possible number. If you just have 1 branch coming off of the ring, then you don't need to say what the number is, because the number of that branch will always be 1 by default. It will always be the priority. And it doesn't matter like if you spin this or not, this branch will always be on carbon number 1. So let's try naming this one. For cyclic hydrocarbons and cycloalkanes for that matter, the parent is always going to be the ring, and the branches will be coming off of that ring. So here I've got a 2-carbon branch coming off of a 6-membered ring. So the 2-carbon branch is an ethyl group, and it's coming off of a 6-membered ring. So that 6-membered ring would be called cyclohexane. So this molecule would be called ethyl cyclohexane. Now, what does it look like if I have more than one group? So let's do that same thing. But now I add a methyl group. I add a methyl group on the other side. All right. Now, how would I name this? So I've got ethyl right here, and I've got a methyl group right there. I still have a 6-membered ring. Well, now I need to number things because now I've got 2 groups, and I need to number things such that the groups, the branches, have the smallest possible numbers. So ethyl will come before methyl alphabetically. So I'm going to start numbering here at 1. 1 is going to be where the ethyl group is located. Then it goes 2, 3, 4, 5, 6. That's wrong because then my groups would have 1 and 5. I want to go the other way. I want to go 1, 2, 3, 4, 5, 6. 1, 3, or 1, 3 is better than 1, 5. So when I write this out, it'll be 1 ethyl, 3 methyl, cyclohexane. And that's basically it for naming cycloalkanes. The root name is going to just get the prefix cyclo, and the root name comes from however many carbons are in that cycle. In the next video, we'll look at cycloalkenes and cycloalkynes. One more thing though is pay attention to the general formula for cycloalkanes. So if you look at all these formulas, they're going to have a general formula where you have n number of carbons, and the number of hydrogens is always going to be twice that number, which should look familiar. That's also the general formula for alkenes. So alkenes and cycloalkanes will have the same molecular formula, which makes those two things kind of interesting. And there will be more on that when you get into Chem 30. All right, I'll see you in the next video. Bye.